Okay. So what exactly electromagnetic induction? Electromagnetic induction I can consider is the free electrons. Listen carefully. The free electrons of copper wire, okay, they can be induced. That means they can be forced to get aligned in one direction. Students. और ये किसकी वजह से होगा? External magnetic field की वजह से. लेकिन कौन सा field होना चाहिए? So there should be a varying magnetic field. So the time when I told you in the last lecture, if in case if you recollect the last session which I said it, at the end of it, I just gave you an introduction. That electromagnetic induction we consider is the free electrons, the free conduction electrons of copper wire, okay, gets induced unidirectionally due to external varying magnetic field, thus generating induced EMF, thereby having induced current. Listen carefully. Electromagnetic induction is free conduction electrons. Free electrons, जो free electrons है, which are in the copper wire, they get induced. That means we are forcing them. So it's induced का मतलब we are forcing them to get aligned in one direction, unidirectionally. So if all the electrons which are random, when they align in one direction, what exactly that results in? That results in current. But what causes them to get in one direction? That is due to external and a varying magnetic field. External and varying magnetic field. Because of that, what happens? They all get aligned in one direction, thus generating induced EMF and having an induced current. This is what we call as electromagnetic induction. Anushka, is the writings, is the audio video fine with you?
Yes.
Yeah. Okay, can you see it properly? The board is also clear?
Yes.
Is it readable?
Yeah.
Okay, so now when I speak about यानी see in general electromagnetic induction को समझना क्या है, तो तुम्हें सिर्फ यही बोलना, अगर किसी ने भी पूछा तो तुम्हें ये बोलना है कि इलेक्ट्रॉन्स रैंडम होता है कॉपर वायर के अंदर, लेकिन अगर वो इलेक्ट्रॉन्स को you try to align them in one direction, so how do you force them to get aligned in one direction? Well, you need a help of what? You need a help of external magnetic field. Lekin what kind of magnetic field you need? You need a varying magnetic field. If such a varying magnetic field has been provided to the free electrons, what happens? All the electrons gets aligned in one direction, and that results in induced EMF. EMF stands for electromotive force, which I told you in current electricity. Thereby, it generates induced current. We are trying to understand this part of it. Now, the person who put forward this particular concept of electromagnetic induction, it is Michael Faraday. So he put forward his own laws. If you recollect the previous chapter, what we did was, listen carefully, previous chapter, what we did was that to every electric field, students, there was a magnetic field. And how are they? Mutually perpendicular to each other. That is, electric field की वजह से हमें magnetic field मिल गई थी. और वो किसने बताया था? Oersted ने बताया था, Hans Christian Oersted. लेकिन now, if I go for a varying magnetic field, am I getting an electric field? Yes, the reverse concept was put forward by Michael Faraday. Students, the reverse concept, due to magnetic field, can I get an electric field? Yes, that part was put forward by Michael Faraday. And he put forward under his laws. And these are called as laws for electromagnetic induction. So now when somebody asks you, what is Faraday's first law? On to electromagnetic induction. Then students, the first law actually speaks about, the theoretical approach. The answer is, students, first law speaks about simply theoretical approach towards the generation of current. What exactly said it? First law states that rate of change of magnetic flux linked with a closed coil produces an induced EMF, and the induced EMF lasts until the change lasts, students. So rate of change rate of change of magnetic flux linked with a closed coil. Students, closed copper coil. Rate of change of magnetic flux linked with a closed copper coil produces an induced EMF. Produces an induced EMF, and the EMF lasts until the change lasts. ये है उसका statement. Students, let us understand the statement now. Rate of change of magnetic flux linked with a closed coil produces an induced EMF and the EMF lasts until the change lasts. Students, अगर तुम ध्यान से अगर तुम सुनोगे तो ये मैंने बता दिया था last lecture में. If you recollect, students, what did I tell you? What did I tell you? I made you to assume. I made you to assume that suppose if I happen to give you a given plane, okay, and on this particular plane of sheet or a plane of cardboard, students, if I give you some compass needles, मैंने कुछ compass needles सुना दिए, okay, and they are placed in circular pattern, and think that there is no Earth's magnetic field. Students, are you getting it? Earth magnetic field है ही नहीं. अर्थ का मैग्नेटिक फील्ड है ही नहीं. मैंने सिंपल कार्डबोर्ड लिया हुआ है, आई हैव पुट सम कंपास नीडल्स इन अ सर्कुलर पैटर्न के अंदर मैंने रखा हुआ है, और सोचो कि अर्थ का मैग्नेटिक फील्ड है ही नहीं, तो मुझे बताओ हाउ एक्जेक्टली द कंपास नीडल विल अलाइन. तो विल से सर द कंपास नीडल्स आर गोइंग टू अलाइन रैंडमली. ये एक रैंडम अलाइनमेंट है. दैट मींस दे आर इन एनी पॉसिबल डायरेक्शन वी कंसीडर. आई गेटिंग इट? दे आर ऑल इन एनी पॉसिबल डायरेक्शन वी कंसीडर. स्टूडेंट्स, तो ये क्या हुआ? ये रैंडम मोशन, यानी हमने अज्यूम क्या किया, ईच एंड एवरी कंपास नीडल को आई हैव अज्यूम स्टूडेंट एज अ फ्री इलेक्ट्रॉन. Please understand very clearly how to get this concept. तो ये सोचो कि ये कॉपर वायर है, ये कॉपर वायर है, और ये है उसका क्रॉस सेक्शनल एरिया. This is the cross sectional area of this particular copper wire. Inside this copper wire, what exactly? There are free electrons. Look at the free electrons. All those electrons are random. Now, when electrons are randomly placed, is there any current? No, there is no current. So there is no current induced inside it. क्योंकि electrons are random है. Net current 0 है. Now to understand what exactly. So now suppose if I happen to take a magnet. Suppose if I take a bar magnet, and take this magnet closer and away. That means think as if I'm taking a magnet and taking closer and away, closer and away, closer and away. That means I'm taking towards the mouth of the circle and away from the mouth of the circle. What are you trying to do? Agar suppose if I'm taking the magnet very close, think the magnet is over here. In the first case, students, will you find out the field lines passing through it? Please pay attention. ये field line है, ये field line होगी, ये field line होगी. Will you find out the field line is passing through it? You will say नहीं sir, क्योंकि magnet बहुत दूर है. जैसे तुम magnet को नजदीक लेके आओगे ना उसे, the field lines are passing through it. The field lines are passing through it. The field lines are passing through it. That means you're trying to increase the magnetic field. That means what are you trying to do? You're trying to increase the flux. Which flux? Magnetic flux. Students, what exactly magnetic flux we consider is? How do you define magnetic flux? So magnetic flux is simply we consider is what? It's B bar dot A bar. It's a scalar product, students. ये सबको पता है. The magnetism I told you. ये है magnetic flux and that is a dot product of B dot A. Magnetic flux का definition क्या है? The answer is, students, what is the definition of magnetic flux? The unit of magnetic flux is simply Weber. Students, the unit of magnetic field intensity I've told you in the last lecture. Weber meter square inverse. Area is simply meter square. Therefore, I'm getting it in terms of Weber. What is magnetic flux, students? Number of magnetic field lines passing perpendicularly to the given surface. अगर तुम ध्यान से देखोगे ना तो देखो सारे फील्ड लाइंस परपेंडिकुलरली जा रहे हैं. तो कितने फील्ड लाइंस जा रहे हैं? 3 जा रहे हैं. अगर मैं ये मैग्नेट को दूर रहता हूं तो शायद ही फील्ड पास होगी. Now try to understand this. अगर तुम मैग्नेट को आगे पीछे करते रहते हो students, that means you're moving the magnet to and fro. Can I say it will take some time for its motion? It will take some time for its motion. If I take the magnet closer, you're trying to increase the flux. If you try to take the magnet backward, you're trying to decrease the flux. So students, is there any change in flux? Is there any change in flux? You'll say, yes, sir, there is change in flux. Is this flux changing with respect to time? Yes, sir, it's changing with respect to time. What exactly change in flux we consider? It's the final flux minus the initial flux upon final time minus the initial time. ये हुआ rate of change of magnetic flux. Please look at the statement now. Rate of change of magnetic flux का मतलब क्या हुआ? d phi by dt. Instantly student से अरे सर इसको मतलब आपको differentiate करना पड़ेगा. Yes. अगर मुझे EMF चाहिए mathematically तो मैं इसको differentiate कर सकता हूँ. Students, rate of change of magnetic flux linked with what? The answer is now. Let's see further. Linked with what? Closed copper coil. Do you see this particular as a closed copper coil? Yes, it's a closed coil. What happens? It produces an induced EMF. Induced EMF का मतलब, is there any current generated? Yes, there is current generated. How? जैसे तुम magnet अंदर लेके जाओगे closer to it, students, all the electron, all the compass needle will start aligning. All the compass needle students will start aligning in one direction. If you happen to see, all this particular will start aligning in one direction, we consider. That means you'll find out there's a alignment of all the compass needle in one direction. That shows there is an induced EMF, induced current. अगर तुम north को दूर लेके जाओगे, all will try to flip in the direction opposite. So due to rate of change of magnetic flux, do you have an induced EMF? Yes. That induced EMF will produce induced current? Yes. अभी ये EMF कब तक रहेगा? Students, ये जो मोशनल EMF है, ये तुम्हारा जो मोशन की वजह से हो रहा है, ये कब तक रहेगा? सर जब तक आप बार मैग्नेट को मूव करते रहोगे, जब तक आप बार मैग्नेट को टू एंड फ्रो करते रहोगे, तब तक करंट होगा. When you stop doing it, no current. That means if I take a magnet closer, what happens? All the electrons will start aligning in one direction, we consider. That means all these electrons will move in one direction. This is the motion of electrons. These are electrons will move in one direction. Will there be any current produced? Yes, there will be current produced in this particular device, in this particular copper wire. See the flow of current. How do you come to know about the current? How do you come to know about the current? Students, if in case if I connect a galvanometer over here, क्या होगा? So the galvanometer will show me a deflection. Students, क्या ये clear हुआ? Is this clear with you? When the north is approaching, see these are the field lines. These are the field lines. These are the field lines. All the electrons goes in one direction. ये कौन सा flow हुआ? ये हुआ electron flow. ये हुआ electron flow. What about the current? What we look into it? We always show the conventional current, students. Conventional current is always in the direction opposite to the motion of electrons we consider. Is that clear? So in this case, if a north is approaching towards the face of the coil, we consider, sorry, the direction of conventional current will be different. Suppose I'll take this as south, students. Let me put in this manner. This is north. My direction of current will be, students, anti-clockwise. This will be the direction of current. ये होगा तुम्हारा direction of current, students. It will be in the direction opposite. This is how the direction of current. And the electronic flow will be opposite, students. Electron flow will be in this direction. This is electron flow. And students, this becomes your conventional current. Is this clear? So all the electrons inside will flow in one direction. This is the unidirectional flow of all the electrons. All the electrons will go in one direction, students, and that will lead to current. So now look at the first statement. What is the first statement, students? Rate of change of magnetic flux, change in flux with respect to time. And if that is linked with a closed copper wire, what happens? You're forcing all the electrons to align in one direction. That results in what? Induced EMF. Will that EMF will reach to current? Yes, it will lead to induced current. लेकिन ये कब तक रहेगा? कब तक current रहेगा? जब तक motion रहेगा magnet का. जब तक there is change in the flux. अगर तुमने magnet को रुका दिया, no current. Galvanometer will show me zero deflection. Is this part clear to all of you? Is it clear, students? Okay. Fine. तो ये हुआ तुम्हारा स्टूडेंट्स फैराडेज फर्स्ट लॉ. सो जब भी तुम्हें समझना तो तुम्हें ये ध्यान में रखना जरूरी है कि चेंज इन मैग्नेटिक फ्लक्स होना चाहिए विद रिस्पेक्ट टू टाइम. नाउ दिस वाज थियोरेटिकल अप्रोच. पीपल आस्क्ड माइकल फैराडे कि चलो तुमने थियोरी बता दिया कि मैग्नेट को अगर तुम कॉपर वायर के नजदीक लेके जाओगे तो वहां पे डिफ्लेक्शन होगा. और कैसे पता चलेगा? गैलोमीटर के देखते हुए पता चलेगा. लेकिन नाउ पीपल आस्क्ड माइकल फैराडे हाउ डू यू मेजर दिस ईएमएफ? तुम ईएमएफ को मेजर कैसे करोगे? सो फैराडे पुश्ड फॉरवर्ड द सेकंड लॉ. He put forward the second law, and that is Faraday's second law states what? Second law speaks about the mathematical representation, students. What is a mathematical representation? The rate of change of magnetic flux is directly proportional to the induced EMF. The rate of change of magnetic flux, students, is directly proportional to the induced EMF of the closed coil we consider. So E is proportional to d phi by dt. E is proportional to what? D phi by dt, and that becomes your mathematical relations. I repeat, the rate of change of magnetic flux is directly proportional to the induced EMF we consider. अगर तुम्हारा ये change बढ़ेगा तो EMF बढ़ेगा. अगर ये change, if I'm taking it at a very slow rate, what happens? EMF will decrease. That means suppose if I move the magnet very fast, what's going to happen? There'll be growth in EMF. But if I take the magnet gradually towards, gradually away, if the motion is very slow, students ध्यान से सुनना, motion is very slow, यानी change हो रहा है, flux change हो रहा है, flux बढ़ रहा है, flux कम भी हो रहा है. लेकिन is the time taken less? No, sir. You are taking more time for the change in flux. तो अगर time बढ़ेगा तो EMF कम हो जाएगा. So now the mathematical representation is what? E is proportional to d phi by dt. When I remove the symbol of proportionality, students, you'll be getting it as minus with a constant and change in magnetic flux upon time, students. So what's the formula? Your E is equal to minus n d phi by dt. I repeat, this is the second law. Second law, Faraday's second law states that the rate of change of magnetic flux is directly proportional to the induced EMF, and the EMF lasts until the change lasts. But now suppose if I happen to consider, if I remove the symbol of proportionality, what am I going to get? I'm going to get a constant. What is the constant over here? Is number of turns. What does negative sign speaks about? Lenz's law, and that speaks about law of conservation of energy. So students, first law speaks about theoretical approach. Second law speaks about mathematical approach. So what's the formula? Therefore, E is equal to negative n d phi by dt. Is this clear to all of you now? Students, is this clear? Students, do say yes or no, so that it's only Anushka is responding. What about the rest of them? Ananya, Ayush, what exactly? Jana, Garv, at least reply. हाँ या ना, तो फिर आगे बढ़ो करके. I go, it's of no use just sitting into the lectures and not saying anything.
Yes, sir.
Okay, fine. Oh, puja is going on in the background. Okay, doesn't matter. Okay, now can I erase this, students? क्या मैं इसको erase कर दूं? इसके बारे में ध्यान रखना स्टूडेंट्स. ये मैं वापस बताऊंगा कि मैंने डायरेक्शन ऑफ करंट कैसे लिया और इलेक्ट्रॉन फ्लो कैसे लिया. आई विल टेल यू अबाउट दिस. राइट नाउ आई एम गोइंग टू स्पीक अबाउट दैट ओनली. So you don't have to memorize this. You'll understand still better. So the first law is theoretical approach. Second law is a mathematical approach. Okay, sure. So the formula we consider is your induced EMF is directly proportional to rate of change of magnetic flux. Since magnetic flux is given by the formula B dot A, okay? Do keep this in mind. Therefore, E is equal to negative L into D phi by B experience. What exactly N over here stands for? N stands for number of turns. Number of turns. Each negative sign क्या है? So negative sign speaks about Lenz's law. It speaks about Lenz's law. It says that direction, the answer is not means direction of induced EMF or induced current in a closed coil is such that it opposes the cause which produces the change. Now, the answer is students. Many students don't understand this part. Many students, negative sign when I put over here speaks about Lenz's law, students, or Lenz's law we can consider, apostrophe S you can consider. Direction of induced EMF or induced current in a closed coil is such that it opposes the cause which produces. अभी हमें ये समझना है, हमें ये नेगेटिव साइन के बारे में समझना है. पहला वाला तो आ गया था, वो कैसा था? लॉ के हिसाब से था. To understand this, students, let us go for a few diagrams. Please pay attention very clearly. ध्यान से सुनना. Think as if कि मेरे पास एक circular coil है, students. Okay, I have a circular coil. Okay, and I'm connecting the circular coil to a galvanometer, students. Okay, and this galvanometer is centrally zero. This is the first diagram, students. I think this is the second diagram I'm having. Okay, this is the third diagram I'm having it. With centrally zero. Okay. Think as if I'm keeping. Please pay attention. How is the diagrams with? These are all circular coils. ये सोचो कि circular coil ऐसा है, students. Diagram मैंने भले ऐसे दिया है, students. I've drawn it on a plane, but think as if the coil is in this manner. And I'm keeping a magnet. The magnet is coming to and fro. Yani this is the face of the coil. Students, this is the face of the coil. ये है face of the coil. So I'm keeping the face in this manner. Now look over here. I have a magnet. In the first case, में क्या कर रहा हूँ मैं? The magnet was far away. Okay, it's a bar magnet. I'm taking it. Okay, the magnet is far away, students. Is that clear? Then what I'll do, I'm trying to take the magnet closer. Okay. Again, I'm taking the I'm stopping the magnet. In the third case, I'm stopping the magnet. That is no motion. Coil at rest. Over here also coil at rest. What does this stands for? Galvanometer. This coil is also at rest. Since this magnet is moving towards, it's going towards, it has approached towards it. One more diagram where I can show it. One more diagram I can show it where I'm taking the magnet far away. Answer देखना students. Magnet को मैं दूर लेके जा रहा हूँ. Okay, and see the coil. Yani when you're trying to understand this, students try to go for these four diagrams. And what is the order? This is the first diagram. This is your second diagram. This is your third diagram, and you take this as the fourth diagram. Please, are these four diagrams first of all clear to all the students? Then I can proceed further. क्या ये चार diagram clear हुआ है? These are four circular coils. There is no current. Students, किसी में भी current नहीं है. मैंने यहाँ पे battery भी connect नहीं किया है. उसके अलावा मैंने क्या कनेक्ट किया, गैल्वेनोमीटर कनेक्ट किया। एंड स्टूडेंट्स गैल्वेनोमीटर है क्या? गैल्वेनोमीटर इज अ करंट डिटेक्टिंग इंस्ट्रूमेंट, नॉट अ मेजरिंग इंस्ट्रूमेंट. Galvanometer is a current detecting and it's a centrally zero galvanometer. When I have drawn this coil on a whiteboard, you see that it's drawn in this manner. Hello, this is the face of the coil. You might be seeing it, but actually it's not in this manner. It's actually placed in this manner, perpendicular to this. And I'm taking the magnet to and fro. It's like this. क्या ये चार diagrams clear हुआ? Students, सबसे पहले ये बताओ. हाँ students? अरे हाँ या ना तो बोलो. Thank you, Anushka. I'm very, very thankful to you. You are the only one who's responding. I don't know about the rest of the students, what they are up to. Aryan, Garv, Chana, Ayush, Ananya. It's of no use now. तुम अगर reply नहीं करोगे, respond नहीं करो तो unnecessary. I'm just trying to force myself onto you all. Imposition हो रहा है. उसका कुछ फायदा नहीं है फिर. बैठे बैठे कुछ समझ में नहीं आएगा. वापस रट्टा मारने जाओगे, वापस भूलोगे, वापस रट्टा मारोगे, वापस भूलोगे. Why you trying to make your studies more tougher? अभी ध्यान से देखना स्टूडेंट्स, ये मैग्नेट पहले दूर था. अगर मैग्नेट दूर है स्टूडेंट्स, लुक एट द फील्ड लाइंस, सी द फील्ड लाइंस. दीस आर द मैग्नेटिक फील्ड लाइंस. हाउ मेनी फील्ड लाइंस है? देयर आर 3 फील्ड लाइंस. स्टूडेंट्स, तुम्हारे हिसाब से व्हेन द मैग्नेट इज फार अवे, हाउ मेनी फील्ड लाइंस आर ट्राइंग टू एंटर? विल यू फाइंड आउट 3 फील्ड लाइंस आर ट्राइंग टू एंटर, ओनली वन? यू से सर ओनली द सेकंड वन इज पासिंग. ये तो शायद ऐसे चला जाएगा. Garv, your mic is on, my dear. It seems that you are. Okay. Only one magnetic field line is passing through. Now listen carefully. Listen carefully. Let us assume that the flux passing in the first case, initial flux, students, when the magnet is far away, flux is given out formula. So flux is equal to V dot A. Flux का unit क्या है? Weber. Students, Weber. B का unit क्या है? Weber per meter square. Area meter square. How much is the flux? Let us assume that the flux is 1 Weber. Only one line is passing through it. What is magnetic flux, students? What is magnetic flux? चलो तुम लोग ने electrostatics पढ़ा students. What is electric flux? What is electric flux? Number of electric field lines passing normally through a given surface. Magnetic flux क्या है? Number of magnetic field lines passing normally through a given surface. यानी अगर suppose मैं एक coil देता हूँ, circular coil देता हूँ, and if I'm saying that these are the field lines passing through it, if there are 3 field lines passing, the flux is maximum. See the coil is in this manner. If I show it, this is the face area. If I say these are 3 lines passing through it, flux ज़्यादा है. अगर मैं बोलूँ how many lines are passing through it, how are the field lines? Perpendicular. So how much is the field line passing through it? Initial flux this time, it's 1 Weber. Let us say the initial time. Initial time I'll consider 0 seconds. अभी मैंने क्या किया, मैग्नेट को नजदीक लिया स्टूडेंट्स. आई एम टेकिंग द मैग्नेट क्लोजर. जैसे मैं मैग्नेट को नजदीक लेता हूँ स्टूडेंट्स, टेल मी हाउ मेनी फील्ड लाइंस नाउ कैन पास थ्रू इट. विल से नाउ आई फील दैट ऑल 3 लाइंस विल पास थ्रू. है ना, नजदीक लोगे तो तीनों 3 पास हो जाएंगे. तो नाउ व्हाट एक्जेक्टली द फ्लक्स इन द सेकंड केस? द फाइनल फ्लक्स विल बी 3 वेबर. Let us say the time taken for it, time taken to move from here till here, let us say the final time is 3 seconds. So do we have change in magnetic flux? Do we have change in magnetic flux? We'll say yes sir, we have change in magnetic flux. How do you find out the change in magnetic flux? Formula क्या है? Sir, E is equal to minus n d phi by dt. Forget about negative sign for the time being. Negative sign को मारो गोली for the time being. Don't need. We are trying to understand negative part के लिए. N का मतलब मैंने क्या बोला था? Number of turns. कितने turns तुम्हें दिखाई देते हैं? ये कॉपर वायर के कितने टर्न्स दिखाई दे रहे हैं? क्या 50 टर्न्स दिखाई दे रहे हैं? 100 टर्न्स दिखाई दे रहे हैं? नहीं, एक ही टर्न है ना. तो डाल दो ना. E is equal to 1 into what is change in flux? Final minus initial. So it's 3 minus 1. In how much time? 3 minus 0. Yeah, I can consider in time 2 seconds. Let me take it more easy calculation. 2 seconds में हम लोग यहाँ पे पूछे. So can you tell me what is the EMF? So 3 minus 1 is 2. 2 upon 2. What's my answer? So my answer will be 1 volt. This is an EMF, electromotive force, potential difference. Students, यहाँ पे गैल्वेनोमीटर के अंदर तुम्हें डिफ्लेक्शन दिखाई देगा. The galvanometer will show a deflection onto one side, and there will be an EMF induced. And that EMF will be equal to almost 1 volt. यानी यहाँ पे current flow हो रहा है, current flow हो रहा है. Direction of conventional current students इस direction में हो. ये डायरेक्शन ऑफ करंट इस तरफ जाएगा. इलेक्ट्रॉन किस तरफ मूव होंगे स्टूडेंट्स? इलेक्ट्रॉन्स का डायरेक्शन ऑपोजिट होगा. इलेक्ट्रॉन्स आर गोइंग टू मूव इन दिस डायरेक्शन. यानी स्टूडेंट्स इफ लुक ओवर हियर, ये तुम्हारा पॉजिटिव पोटेंशियल हो जाएगा, ये तुम्हारा नेगेटिव पोटेंशियल. दैट्स हाउ द डायरेक्शन ऑफ करंट. सो कैन यू सी करंट ओवर हियर? यस. हाउ डू यू कम टू नो? यू कांट सी इनसाइड ना, यू कांट सी इनसाइड द कॉपर वायर. तुम क्या देखोगे? तुम गैल्वेनोमीटर को देखोगे भाई. क्या गैल्वेनोमीटर में डिफ्लेक्शन दिखाई दे रहा है? हाँ सर डिफ्लेक्शन है. उसका मतलब क्या हुआ? इज देयर एनी करंट? यस. अगर किसी ने पूछा हाउ मच इज द पोटेंशियल डिफरेंस अक्रॉस दिस, तो तुम क्या करो? गैल्वेनोमीटर को निकाल दो ना, वोल्ट मीटर लगा दो यहाँ पे भाई. तो वोल्ट मीटर क्या मेजर करेगा? पोटेंशियल डिफरेंस. Students, am I getting an induced EMF? Yes, sir. And that is because of what? There was change in flux. Flux was less, flux is more. क्या ये first and second diagram clear हुआ along with the mathematical part? Students, is the first and the second diagram clear along with the mathematical part? Students? Okay. Now what I'm trying to do? Now I'm trying to pull the magnet backwards. Students, जैसे मैं मैग्नेट को पीछे लेने जाता हूं, होगा क्या? होगा क्या? ये जो इलेक्ट्रॉन्स का मोशन इस तरफ था, ध्यान से सुनना स्टूडेंट्स, सारे इलेक्ट्रॉन्स का मोशन ऑपोजिट हो जाएगा. इलेक्ट्रॉन्स का फ्लो ऑपोजिट हो जाएगा. कन्वेंशनल करंट कैसा होगा? कन्वेंशनल करंट का डायरेक्शन भी चेंज हो जाएगा. यानी जो एंड पॉजिटिव था, जो एंड नेगेटिव था, अभी क्या होगा? ये पॉजिटिव होगा, ये नेगेटिव होगा. Are you getting it? So in that case, what exactly? Will the deflection the galvanometer also will get reversed? Yes. यहाँ पे on one side of zero, यहाँ पे on other side of zero. क्यों? Because north is going away. यहाँ पे north is going towards the coil, towards the face of coil, and this is going away from face of coil. And what are you trying to do? So you're trying to reduce the field. I'm trying to decrease the flux. I'm trying to decrease the flux. The flux is decreasing. Oh, yeah, the flux is increasing. लेकिन क्या यहाँ पे भी EMF जनरेट होगा? हाँ सर होगा. हाँ सर होगा, क्योंकि इनिशियल क्या है? 3 वेबर्स टाइम 0 सेकेंड्स. जैसे तुमने पीछे लिया तो फाइनल कितना होगा? 1. यहाँ का आंसर क्या आएगा? यहाँ का क्या आंसर आएगा? सर फॉर्मूला तो यही होगा. नंबर ऑफ टर्न्स 1. यस. So E is equal to number of turns 1. Yes, sir. Final flux. So final to 1 हो जाएगा. Initial 3. Let us say the time taken is 2. What's my answer? -1 volt. ये देखो, +1 volt. ये -1 volt. Is there any EMF? Yes. But has the direction of EMF got reversed? Yes. The direction of EMF have got reversed. ये कब तक रहेगा? जब तक तुमने पीछे लिया तब तक. लेकिन अगर सपोज ये नॉर्थ को मैंने बहुत दूर ले लिया, अगर मैं मैग्नेट को ज्यादा पीछे ले लूं, तो अभी फील्ड तो पास ही नहीं हो रही है ना. देयर इज नो ईएमएफ, नो करंट. So what exactly the reason for the current? The magnet should be closer to the coil and it should move to and fro, to and fro, to and fro all the time. Time taken should be very small. EMF will be more. But now what do you do? Look at the fourth case. फोर्थ केस में मैंने क्या किया स्टूडेंट्स? फोर्थ केस में मैंने मैग्नेट को लिया नजदीक, लेकिन अभी ये मैग्नेट को मूव ही नहीं कर रहा हूं मैं. द मैग्नेट इज नॉट इन मोशन, द कॉइल इज आल्सो एट रेस्ट. आर देयर फील्ड लाइंस पासिंग? यस सर, देयर आर फील्ड लाइंस आर पासिंग ना. You will find out field lines are passing. You will find out the field lines are passing. What is the field line? What is the initial field line? So initial field line is 3 Weber. What is the final field lines? That is also 3 Weber. Is the magnet in motion? No. You've waited for 3 seconds, no motion. 5 seconds, no motion. 10 minutes, no motion. Students, what is the formula? What is the formula for EMF? Sir, EMF is equal to number of turns is 1 चेंज इन फ्लक्स यानी फाइनल 3 lines, initially also 3 lines, time taken 5 seconds, 3 minus 3 is 0, EMF is 0 volt. Will this galvanometer will show deflection? No, your pointer will be exactly at 0. Students, यहाँ पे pointer एक तरफ जा रहा था जब ये magnet नजदीक आया. I get it. You can consider. You can take the pointer on the opposite direction when the magnet is going away. Lekin when the magnet was at rest, was there any deflection? No. Why? Why? What's the reason? Then a student who's wise and smart will say there is no change in magnetic flux. So d phi is 0 है. Change in flux 0 है. अगर change in flux 0 हुआ तो आपका numerator 0 हो गया. अगर numerator 0 होगा तो EMF 0 ही आएगा. So now did you understand the law? The rate of change of magnetic flux linked with a closed coil produces an induced EMF at the ends of the coil, and the EMF lasts. EMF lasts until the change lasts. Change in magnetic flux lasts. When there is no change in magnetic flux, and a change in magnetic flux is 0. Current is also 0. EMF is also 0. Is these 4 diagrams clear to all the students? These are the 4 diagrams clear to all of you. Now, when I speak about for negative sign, what's the reason for the negative sign? That is to obey law of conservation of energy, Lenz's law. So let's look over here. People normally ask कि सर अगर जब आप नॉर्थ को नजदीक लेके जाते हो तो आपने करंट को कैसे लिया? ध्यान से सुनना students. See, we are trying to understand that there is some amount of work done. So जैसे तुम नॉर्थ को नजदीक लेके आते हो, स्टूडेंट ध्यान से सुनना, नॉर्थ को नजदीक लेके आते हो तो what are you trying to do? Sir, you are generating current. Everybody, please for another 2 minutes, listen carefully. Sir, you are generating current. That means we are producing electrical energy. So can you tell me what is a transformation of energy? Sir, mechanical energy due to moving magnet. Please, everybody with me. Mechanical energy due to motional magnet is getting converted into electrical energy. Is it obeying law of conservation of energy? Yes. So can energy be created? No. Can energy be destroyed? No. Can energy be transferred from one form to another? Yes, sir. यहाँ पे mechanical energy, which is also a kind of a magnetic energy, we have it. It's getting converted to electrical energy. यानी there is some work done. Yes, there is some work done. कैसे? जब भी ये नॉर्थ को तुम नजदीक लेके आओ तो स्टूडेंट्स ध्यान से सुनना, तो ऑटोमेटिकली यहाँ पे एक पोलैरिटी डेवलप होती है स्टूडेंट्स. See, what is a polarity developed? When the north of the bar magnet is approaching towards a coil, the polarity at the coil is north. Automatically it developed a polarity. तो ये नॉर्थ क्या इसको सपोर्ट कर रहा है या अपोज कर रहा है? अपोज करेगा. ध्यान से देखना स्टूडेंट्स, जैसे तुम नॉर्थ को नजदीक लेके आओगे, उसको एक रिपल्शन मिल रहा है, फिर भी तुम नजदीक लेके आ रहे हो, यानी यू आर फोर्सिंग द इलेक्ट्रॉन्स टू गेट अलाइन्ड. तो जैसे तुम नॉर्थ नजदीक लेके गए, सारे इलेक्ट्रॉन्स आर मूविंग इन दिस डायरेक्शन. व्हाट एग्जैक्टली इट लीड्स टू कन्वेंशनल करंट. यानी of course work done in moving the magnet. Students, work done in moving the magnet against the opposing force. Work done in moving the magnet against the opposing force produces induced EMF. और ये जो वर्ड ऑपोजिशन है ना, ये जो वर्ड ऑपोजिशन में बोल रहा ना, that is the negative sign. तो नेगेटिव साइन का मतलब क्या है? Opposes what? The magnetic flux. If the magnetic flux is trying to enter inside, try to oppose it. So the polarity will be north. So it opposes the cause which produces a change. अब यहाँ पे देखो स्टूडेंट, यहाँ पे देखो, क्या नॉर्थ नजदीक आ रहा है पीछे जा रहा है? नजदीक आ रहा है पीछे जा रहा है, तो तुरंत बोलेगा सर यहाँ पे नॉर्थ तो पीछे जा रहा है. तो यहाँ पे स्टूडेंट्स क्या फ्लक्स बढ़ रहा है या फ्लक्स कम हो रहा है? फ्लक्स कम हो रहा है. You have to do some work. You have to do some work. How can you do work? How can you do work? सर ऐसा करते हैं ना, यहाँ पे एक साउथ पोलैरिटी डेवलप कर लो. तुम मैग्नेट को पीछे लेके जा रहे हो, लेकिन पोलैरिटी यहाँ पे अगर साउथ होगी तो क्या मैग्नेट को तुम पीछे ले जा सकोगे? नहीं. क्यों? क्योंकि ऑल द टाइम इस मैग्नेट को एक अट्रैक्टिव फोर्स होगा. So are you going to do some work? Yes, I'm going to do some work against the flux. We consider flux is trying to decrease, this south is trying to increase the flux. So can I say over here also we are trying to oppose the flux, oppose the flux, oppose the flux. That means if the flux is trying to increase, if the flux is trying to increase, oppose it, try to decrease. If the flux is trying to decrease, if the flux is trying to decrease, oppose it, try to increase. And what is this flux? What is this flux? Flux is a cause. Flux is a cause. For what? For what? To produce the current, to produce the change. So students, what does Lenz's law states at? Lenz's law speaks about direction of induced EMF or induced current in a closed coil is such that it opposes the cause which produces a change. So हमेशा ये ध्यान रखना स्टूडेंट्स, जब भी नॉर्थ का बार मैग्नेट अगर फेस के तरफ जाएगा तो वहां पे पोलैरिटी नॉर्थ ही होगी, इसके पीछे की तरफ साउथ हो जाएगा. अगर नॉर्थ दूर चला गया तो वहां पे साउथ पोलैरिटी आ जाएगी, पीछे की तरफ नॉर्थ होगा. अगर मैग्नेट रेस्ट पे है, नो इंड्यूस्ड ईएमएफ. Is this Lenz's law clear with you along with the diagram? It obeys what? The Lenz's law simply students, when anybody asks you what does Lenz's law obeys, the Lenz's law obeys law of conservation of energy. Students, ये ध्यान में रखना. Is this part clear to all students? Students, is it clear? So whenever they ask you what exactly Lenz's law, students, Lenz's law states that the direction of induced EMF, induced current in a closed coil is such that it opposes the cause which produces it. What is the formula for induced EMF? Induced EMF is given the formula negative N into d phi by dt. We consider. What does N over here stands for? Number of turns. What does this stands for? Flux. What does d phi stands for? Change in flux. Final minus the initial. Final minus the initial. What does T stands for? Time taken for the change in flux. That means यहाँ पे मैग्नेट मोशन में है, यहाँ पे भी मैग्नेट मोशन में है, यहाँ पे भी मैग्नेट मोशन में है. कॉइल एट रेस्ट, कॉइल एट रेस्ट, कॉइल एट रेस्ट. यहाँ पे मैग्नेट इज आल्सो एट रेस्ट, कॉइल इज आल्सो एट रेस्ट, नो चेंज इन फ्लक्स. अभी तुरंत ऑपोजिट कर देते हैं स्टूडेंट्स, अभी इसी का ऑपोजिट करते हैं. ध्यान से देखना स्टूडेंट्स, अभी मैं क्या करता हूँ, मैग्नेट को रेस्ट पे रखता हूँ. स्टूडेंट्स, मैग्नेट को मूव मत करो, कॉइल को आगे पीछे लो. तो वही हुआ ना स्टूडेंट्स, मैग्नेट को ऐसे रखा, अगर मैं कॉइल को नजदीक लेके जा रहा हूं तो फ्लक्स बढ़ेगा, लाइंस बढ़ेगी. अगर मैं पीछे लूंगा फ्लक्स कम होगा. यानी सपोज इफ देयर इज अ नॉर्थ ऑफ अ बार मैग्नेट एंड इफ आई टेकिंग द कॉइल क्लोजर टू इट, व्हाट्स द पोलैरिटी ओवर हियर विल बी नॉर्थ. पीछे की तरफ साउथ हो जाएगा स्टूडेंट्स, यहाँ पे नॉर्थ होगा. यानी जैसे मैं कॉइल को नजदीक लेके जाऊंगा एक रिपल्शन मिलेगा, फिर भी मैं उसको पुश करूंगा मींस आई एम डूइंग सम वर्क, आई एम टेकिंग द कॉइल एंड मूविंग इट क्लोजर. Will the coil is getting the force of repulsion? Yes, but still, am I doing some work? Yes. The mechanical energy of mine is getting converted to electrical energy, students, and that is what we call Lenz's law, opposes the cause which produces a change. So negative sign अगर किसी ने पूछा उसका मतलब क्या है? Lenz's law. Lenz's law क्या बताता है? Direction of current. किसमें? Circular coil में. कैसे? It opposes the cause which produces it. तो अगर मैंने मैग्नेट को रेस्ट पे रखा, कॉइल को आगे लिया, नॉर्थ है, कॉइल को आगे लिया तो नॉर्थ पोलैरिटी. अभी देखो ये नॉर्थ है, कॉइल को पीछे लो, ऑटोमेटिकली साउथ पोलैरिटी हो जाएगा. तुम पीछे लेना चाहते हो लेकिन पोलैरिटी साउथ है, वो अट्रैक्ट करेगा. तो यू आर ट्राइंग टू डू सम वर्क अगेंस्ट अट्रैक्शन, एंड द वर्क डन बाय यू इन मूविंग द कॉइल बैकवर्ड gets stored in that particular coil in the form of electrical energy. But if the coil and magnet, both of them are at rest, no EMF induced. Is this much clear to all of you? Can I erase it? Okay. So now when I say about if a north is approaching towards the face of the coil, okay. The polarity at the face of the coil will be north. Okay. Approach. Current will be in anti-clockwise direction. पीछे की तरफ south होगा students. Agreed. When the north is receding away, which means the north is going away from the face of the coil, then in that case, how exactly the polarity swings? The direction of current gets reversed. Deflection also gets reversed. The polarity at the face of the coil will be south. यहाँ पे current anti-clockwise होगा, यहाँ पे current clockwise होगा, तो इस तरफ north. Now, if I say if a north south is approaching towards the face of the coil, the polarity at the face of the coil will be south. It should repel, oppose करना है, ये ध्यान रखना. साउथ नजदीक आएगा तो साउथ हो जाएगा, अगर साउथ दूर चला गया तो पोलैरिटी क्या हो जाएगा, नॉर्थ. यानी यहाँ पे करंट कैसे होगा, क्लॉकवाइज जाएगा. ये तुम्हारे दो कनेक्टिंग पॉइंट्स है गैल्वेनोमीटर के, ये होगा तुम्हारा नॉर्थ इज गोइंग, सो इट विल बी साउथ. करंट विल बी इन व्हाट डायरेक्शन, एंटी क्लॉकवाइज. लेकिन अगर दोनों रेस्ट पे है, नो इंड्यूस्ड ईएमएफ. Formula for induced EMF is what? Your EMF is equal to negative N into change in flux, the phi by dt. Final flux minus the initial flux. What does N over stands for? Number of turns. If I increase the number of turns, can I say I'm increasing the EMF also? Yes, I'm increasing the EMF. What is negative sign over here is Lenz's law. Opposes the cause which produces it. This is what a student should keep in mind. इसी के अंदर अगर सपोज उन्होंने क्वेश्चन भी दिया कि सपोज हमारा सर्कुलर कॉइल, स्टूडेंट्स ये एक सर्कुलर कॉइल है, कॉपर का कॉइल है, और मैंने एक मैग्नेट को फ्रीली ड्रॉप किया. स्टूडेंट्स, आई एम ड्रॉपिंग द मैग्नेट फ्रीली, सो इट्स अ फ्री फॉल. ठीक है, ये मैग्नेट का फ्री फॉल हो रहा है. मुझे बताओ जब ये नॉर्थ नजदीक आएगा स्टूडेंट्स तो क्या होगा? व्हाट हैपेंस व्हेन नॉर्थ इज कमिंग क्लोजर टू इट? व्हाट्स द पोलैरिटी ओवर हियर? सर यहाँ पे नॉर्थ होगा, नीचे की तरफ साउथ होगा. यानी यहाँ पे तुम्हें करंट एंटी क्लॉकवाइज दे रहेगा, तो ये क्या, ये सपोर्ट कर रहा है या अपोज कर रहा है स्टूडेंट्स? क्या करेगा ये नॉर्थ पोलैरिटी, क्या करेगा? अपोजेस द मोशन. यानी will the motion accelerate or will the motion will be retarded? हाँ स्टूडेंट्स, यहाँ पे कौन सा मोशन होगा? जब ये नीचे की तरफ आ रहा है स्टूडेंट्स तो तुम्हारा क्या होगा? मोशन रिटार्डेड होगा. क्योंकि इसको अपोज कर रहा है. एब्सोल्युटली करेक्ट. अभी देखो जैसे तुम्हारा मैग्नेट नीचे की तरफ आया स्टूडेंट्स, जैसे तुम्हारा मैग्नेट नीचे की तरफ आया, अभी देखो ये वाला साउथ आया और ये नॉर्थ आया. नाउ इफ आई सी द मैग्नेट इज गोइंग अवे, so if the magnet is going away, then what exactly polarity over here? Only polarity will be changed. Let me draw another diagram for this. Guys, this is the first diagram. This is the second diagram. So this is the first diagram. This is second diagram. This is third diagram. फर्स्ट डायग्राम के अंदर तुम्हें ऊपर वाला फेस नॉर्थ मिलेगा, नीचे वाला फेस साउथ मिलेगा. सेकंड केस में मैग्नेट इज इन बिटवीन. स्टूडेंट्स क्या हो रहा है बताओ? कॉइल के बीच में है मैग्नेट, तो विल देयर बी एनी ईएमएफ इंड्यूस्ड स्टूडेंट्स? नो स्टूडेंट्स, विल देयर बी एनी इंड्यूस्ड ईएमएफ? यहाँ पे मोशन रिटार्डेड होगा. ईएमएफ, हाँ सर ईएमएफ जनरेट हो रहा है, देखो ना करंट दिखा रहा है, तो ईएमएफ, यस देयर विल बी ईएमएफ. हाउ इज द डायरेक्शन ऑफ फ्लो ऑफ करंट? द डायरेक्शन ऑफ कन्वेंशनल करंट इज एंटी क्लॉकवाइज. लेकिन यहाँ पे क्या करंट होगा स्टूडेंट्स सेकंड केस में? हाँ स्टूडेंट्स, यस स्टूडेंट्स, यहाँ पे करंट होगा ही नहीं, तो मैग्नेट इज इन बिटवीन. तो यहाँ पे ईएमएफ क्या होगा सर? ईएमएफ विल बी सिंपली 0 वोल्ट because there is no change in flux. So what if it's moving? It's in motion. It's still in motion. It's moving downwards. जैसे वो बाहर की तरफ निकल गया, it's going away. Which is the polarity over here? South. तो स्टूडेंट्स इस तरफ कौन सा पोलैरिटी होगा? इस तरफ कौन सा पोलैरिटी होगा सर? इस तरफ अगर हमें देखेंगे तो साउथ होगा, ऊपर की तरफ मुझे नॉर्थ दिखाई देगा. यहाँ पे नीचे की तरफ साउथ होगा, ऊपर की तरफ नॉर्थ दिखाई देगा इन दैट केस। Are you getting it? यानी अगर if I have a bottom view in that case, so वो साउथ होगा, यानी यहाँ पे मुझे करंट एस दिखाई देगा, it's in clockwise direction I can consider, यहाँ पे मुझे एंटी क्लॉकवाइज दिखाई देगा, but will there be EMF induced? Yes, लेकिन यहाँ पे क्या होगा? Will the motion is accelerated, motion is retarded over here also? Is the motion accelerated, motion is retarded over here also? यहाँ पे भी तुम्हारा मोशन क्या होगा? Motion gets accelerated. Initially south is trying to pull it. ये south क्या होगा? The face, as I take the south away from it, students, south is going away, so the polarity over here will be north and polarity over here will be south. So देखो ना, south is going away. तो जैसे south away होगा तो क्या होगा? North create होगा. Initial तुम्हें south मिलेगा, लेकिन जैसे नीचे की तरफ जाएगा तो south होगा, तो यहाँ पे north होगा. Opposes the cause. Opposes a cause, we consider. When the north is approaching towards it, the polarity is north. When the north is going away from it, what exactly consider is? When the north is going away from it, what exactly polarity I can consider will be south in this case. लेकिन यहाँ पे south is going away from it, the polarity will be north. Are you getting it, students? So यहाँ पे भी तुम्हारा motion हो रहा है, and there will be an induced EMF generated in both the cases. Is this part clear to all of you all?
Sir,
Yeah.
did you do anything before Lenz's law? Because we had a class till 12.
Yeah, that is the sessions are recorded, my dear. You can have. I just tell about the Faraday's first law, second law. I just put forward that it's mathematical representation and all. I put only that part of it.
Okay.
And then I went directly for the Lenz law part of it, the negative sign. And you are answering, so it's proper. You know it, you know.
Yes, sir, this was there in 10th.
So still the lectures are going on. Chemistry.
No, no, that 12 o'clock one is over.
Okay. At least someone is there to reply, because it was Bechari only Anushka was there. Anushka was the only one who was responding. The rest of them are sitting mum. All of them are sitting mum. Ananya, Ayush, Aryan, Chanakar, all of them are sitting mum. Okay, students. So this was your Faraday's law, and this is your Lenz law, which I made it very clear. So whenever you keep in mind, students, Lenz law speaks about conservation of energy. Is that clear? Now, when I speak about students, the EMF induced, students, listen carefully. Your EMF is equal to negative n into change in magnetic flux with respect to time. Students, flux is equal to what? It's B into A. It's a scalar. Okay, it's a dot product. Okay, its component will be equal to what? B A cos theta. Now, suppose if I go for the formula for E, negative n differentiating B A cos theta by dt. क्या ये clear हुआ? Now, students, we are going for the maths part of it. Okay. So what exactly I'm getting? Induced EMF का formula क्या मिला? से negative n. Agreed. अब देखो students, यहाँ पे now there are ways in which you can generate EMF. Please answer सुनना students. Please answer सुनना. अभी देखो पहला केस में मैं क्या कर रहा हूँ students? Please pay attention. पहला केस में I'm trying to keep your face area and the magnetic field के बीच में angle remaining the same we consider. Okay, they're mutually perpendicular in that case. Okay. तो अगर मैं देखता हूँ फर्स्ट केस के अंदर मैंने क्या किया मालूम है? मैं B को चेंज कर रहा हूँ स्टूडेंट्स, एरिया को कांस्टेंट रख रहा हूँ. प्लीज ट्राई टू अंडरस्टैंड दिस. उसका मतलब स्टूडेंट्स, आई एम टेकिंग अ सर्कुलर कॉइल, ओके, connecting a galvanometer, and I'm changing the magnetic field. How do I change the magnetic field? So you take the magnet to and fro, taking the magnet to and taking the magnet towards and fro in that case. So am I having change in magnetic field? Yes. लेकिन am I changing the face area? Face area of the coil. Face area pi r squared is constant. Will there be EMF induced? Yes, there will be induced EMF. There will be a deflection. तो इसको तुम यहाँ पे कैसे रिप्रेजेंट करोगे? ध्यान से देखना स्टूडेंट्स. E is equal to negative 10. What did I say? So you're keeping area constant, so area cannot be differentiated. Is that clear? So I'll put it as A. Is that clear? Now, when you look into it, answers is not your B and A. Students, what is cos theta? Theta is the angle between external magnetic field and the area vector. यानी स्टूडेंट्स यहाँ पे तुम्हारा cos थीटा आएगा ही नहीं स्टूडेंट्स क्यों नहीं आएगा क्योंकि सर थीटा 0 है थीटा क्या हो जाएगा 0 है तो cos of 0 क्या होगा 1 हो जाएगा नाउ स्टूडेंट विल से सर ऐसा आप कैसे बोल सकते हो कि थीटा 0 है एवरीबॉडी प्लीज बी विथ मी लिसन केयरफुली व्हाट आई टोल्ड यू this is the face of the coin how is the face of the coin please I'm showing it in this manner but the face is in this way can I say this is the face area students what is the area vector what is the area vector of this coin perpendicular to the surface students क्या ये clear हुआ सबको ये जो black pen है वो क्या है area vector हाँ perpendicular surface look at the magnetic field lines how is the magnetic field lines of the magnet see the reading is the reading speaks about the magnetic field yes it speaks about the magnetic field how is the magnetic field how is the magnetic field so the magnetic field is going in the direction देखो ना अगर मैं magnet को नजदीक लेता हूँ तो field lines आ रही है तो how are they both are parallel यानी स्टूडेंट्स ये हुआ एरिया वेक्टर स्टूडेंट्स ये हुआ एरिया वेक्टर ये हुआ मैग्नेटिक फील्ड दोनों पैरेलल है cos of 0 1 हो जाएगा फ्लक्स मैक्सिमम होगा यानी यहाँ पे हम cos थीटा लेंगे नहीं डिफरेंशिएशन के टाइम पे when we differentiate we don't differentiate cos theta in that case तो यहाँ पे तुम्हारा क्या आंसर होगा सर n आपने निकाल दिया एरिया सेम है तो सर आप डिफरेंशिएट करोगे मैग्नेटिक फील्ड विद रिस्पेक्ट टू टाइम कैन आई से दिस इज वन मैथमेटिकल फार्मूला एंड दिस विल गिव मी द आंसर इन वोल्ट एब्सोल्युटली करेक्ट स्टूडेंट्स ये ध्यान में रखना प्रॉब्लम्स में ऐसा पूछते हैं they'll give you magnetic field in that case and differentiate they'll tell you to differentiate it in that case second case में क्या करते हैं second case में ध्यान से सुनना now what I'll do I'll try to keep magnetic field constant B constant area को change करते हैं स्टूडेंट्स ध्यान से सुनना area को change करते हैं but again how is B so B is parallel to A theta is 0 cos of 0 is 1 यहाँ पे भी B is parallel to A students theta is 0 cos of 0 will be equal to 1 what is the second way this is the first way second way क्या है ध्यान से देखना students B is constant area कैसे how do you do it keep B constant changing the area then what do you do students ध्यान से सुनना now try to keep a magnet okay in the first case you try to go for ध्यान से सुनना students you try to go for a square loop connected to a galvanometer of side L okay of side L see the field lines are the field lines passing through it यानी ये जो loop है वो ऐसा है students and the field is passing through it are the field lines passing through it yes the field lines are passing through it so students keep this square loop for a certain instant of time and then what do you do same loop you change it from square to circle and this is the radius of the circle did you change the area students did you change the face area did you change the face area पहले बताओ what is the area of the square loop what is the area of the square loop so the area of the square loop was side square what is the length of the conductor so the length of the conductor was equal to the perimeter of the square and that is equal to the circumference of the circle and circumference of the circle is 2 pi capital R can I students can I find out the face area yes can I get the radius why not radius का formula क्या होगा so 4L upon 2 pi हो जाएगा what's my answer 12 upon pi आ गया तुम्हारे radius now students can you find out the area of the circle face area of the circle yes sir face area of circle क्या हो जाएगा face area of circle क्या होगा pi r square होगा क्योंकि आपको pi r square चाहिए है ना तो pi into r square means can I say 4L square upon pi square एक pi cancel हो गया what's my answer 4L square upon pi स्क्वायर यूनिट्स। स्टूडेंट्स क्या ये क्लियर हुआ? हाँ देखो, yes, yes, you're changing the same square. I'm changing the square into, that's why I see the perimeter of this of the square is equal to the circumference. The same length I'm converting into a circle. तो अभी तुम्हारा फॉर्मूला क्या होगा स्टूडेंट? सेकंड फॉर्मूला क्या हो जाएगा? देखो सेकंड फॉर्मूला क्या होगा? सेकंड फॉर्मूला में डिड आई चेंज द मैग्नेटिक फ्लक्स? नो, आई डिडंट चेंज द मैग्नेटिक फ्लक्स, आई डिडंट चेंज द मैग्नेटिक फ्लक्स। यानी तुम्हारा फॉर्मूला क्या होगा सर? ई होगा, नेगेटिव साइन आएगा, आपने अभी बी को कांस्टेंट रखा, क्या चेंज करोगे? एरिया। आ गया तुम्हारा सेकंड वे ऑफ जनरेटिंग ईएमएफ। समझ में आ रहा है स्टूडेंट्स कैसे कैसे तुम ईएमएफ को जनरेट कर सकते हो? फर्स्ट केस में हमने एरिया को कांस्टेंट रखा, यू चेंजिंग द मैग्नेटिक फील्ड। सेकंड केस में मैग्नेटिक फील्ड को कांस्टेंट रखा, चेंजिंग द एरिया। थर्ड केस में क्या करोगे सर? ए और बी को सेम रखते हैं, हम ऐसा करते हैं ना, रोटेट करते हैं, पूरा इसको रोटेट करते हैं, फेस को ही रोटेट करेंगे, तो फ्लक्स चेंज होगा कि नहीं होगा स्टूडेंट्स? सिंपल। अगर मैं ऐसा रखता हूँ, ये फील्ड है, तो पहले ऐसे, अभी मैं ऐसे रखूंगा तो देखो पैरेलल हो गया, यहाँ पे फील्ड इज कटिंग, ये देखो ये फेस ही है स्टूडेंट्स, ये फील्ड कट कर रहा है। जैसे मैं रोटेट करूंगा, अभी फील्ड कट नहीं कर रहा है, वापस रोटेट करूंगा तो फील्ड विल कट। तो नाउ इन द थर्ड केस व्हाट एग्जैक्टली माय फॉर्मूला? सर थर्ड केस के अंदर मैं क्या करूंगा? ध्यान से सुनो स्टूडेंट्स, E इज इक्वल टू माइनस n कांस्टेंट है, नंबर ऑफ टर्म्स को मैंने कांस्टेंट लिया है, a लिखा है, b है सर डिफरेंशिएटिंग cos थीटा बाय dt। So what is differentiating cos theta by dt? What's my answer? Now students, what is differentiating cos theta? So differentiating cos theta will be minus sin theta. Minus into minus will be plus. What's my answer? N A B sin theta into d theta by dt. What is d theta by dt? It's omega. So what exactly is equal to N A B omega sin theta? And this answer is in volt. ये किसके लिए होगा स्टूडेंट्स? ये होगा फॉर रोटेशन ऑफ कॉइल। ये क्या होगा? रोटेशन ऑफ कॉइल के हिसाब से तुम्हारा इंड्यूस ईएमएफ। This can be rewritten as, students, this can be rewritten as what? E is equal to E naught sin theta. And so this E naught is called as peak EMF. इसको हम क्या बोलते हैं? Peak EMF. I can call this as peak EMF. क्या ये क्लियर हुआ स्टूडेंट्स? Students, is this clear? Ways in which you can generate EMF. What's the formula? अगर किसी ने पूछा changing the magnetic field, of course, come on, it's a waveform, my dear. Sine is a waveform. You will have learned wave motion. Students, wave motion हुआ है कि नहीं हुआ है? हाँ? Students, what is an equation of a progressive wave? बताओ क्या जगन्नाथ, wave motion नहीं हुआ?
We just started that.
हाँ तो what is an equation of a progressive wave? You asked me about restoring force and everything, my dear. What exactly the concept of this thing?
Y equals
हाँ
A sin WT minus KX plus
तो ये
phase.
क्या? You asked me this thing long before, 2 to 3 weeks ago, my dear. So when you say that y is equal to a sine some angle, what does that a stand for? Amplitude नहीं है? ये amplitude नहीं बन गया? Amplitude is the maximum displacement, and maximum को मैंने peak बोल दिया। वहां पे a is the maximum distance, यहाँ पे E naught is the maximum EMF. Maximum का other word क्या होगा? Peak.
Okay.
This is maximum amplitude, students. Maximum amplitude of EMF. I can't use the word amplitude because amplitude goes with respect to distance. This is EMF, so I can call it maximum EMF. Maximum EMF को मैं नाम दूंगा peak EMF.
Yes, sir.
Okay, can I erase this now, students? Please, can I erase this?
Yes, sir.
Okay, please. Since now we go for your how exactly your current and your EMF we consider for an external resistor if I have to consider, okay, is considered to be in terms of d pi by dt. So simply we can get a relation, students, as E is equal to negative d pi by dt. That's one. E can be written in terms of dLV. That's the other one I can consider. I can give an answer for this to consider also. Okay. Uh, we can both get these mathematical relations, students, and that comes under induction and energy transfer, students. It comes under the heading of induction and energy transfer. Before going for this, students, answers will not. Let us go for how to find out the direction of induced current. I repeat, students, this is a kind of a note to keep in mind. अगर किसी ने पूछा direction of induced current in a closed coil पूछा है, तो तुम्हें क्या यूज करना है? लेंसेज लॉ यूज करना है. ये ध्यान रखना है प्लीज. लेंसेज लॉ क्लोज्ड कॉइल के अंदर यानी सर्कुलर कॉइल्स या सोलेनॉइड. लेकिन अगर स्ट्रेट कंडक्टर होगा then should use Fleming's right hand rule. ये ध्यान में रखना. This is an important point which students normally forget it. Students, Fleming's left hand rule किसके लिए यूज किया था? Fleming's left hand rule was used to understand what? Working of a galvanometer, DC motor या तुम्हारा deflection in a galvanometer, है ना? उसके लिए यूज किया था. कौन से चैप्टर में यूज किया था स्टूडेंट्स? ये हमने यूज किया था मैग्नेटिक इफेक्ट ऑफ इलेक्ट्रिक करंट, जिसको हम बोलते हैं शॉर्ट में MEC. स्टूडेंट्स, Fleming's left hand rule is simply used to find out direction of force. Students, फोर्स का डायरेक्शन को निकालने के लिए हम लोग ने फ्लेमिंग्स लेफ्ट हैंड रूल यूज किया था. यहाँ पे हम फाइंड आउट करेंगे डायरेक्शन ऑफ इंड्यूस्ड करंट, तो वी यूज फ्लेमिंग्स राइट हैंड रूल. यानी डायरेक्शन ऑफ इंड्यूस्ड करंट स्टूडेंट्स दो तरीके से तुम फाइंड आउट कर सकते हैं. क्लोज कॉइल या सोलेनॉइड के लिए यूज करना है लेंसेज लॉ. अभी एक वापस मैं लेंसेज लॉ की तरफ बताता हूँ स्टूडेंट्स, ध्यान से सुनना. अगर साउथ इज कमिंग टुवर्ड्स द फेस ऑफ द कॉइल, the polarity at the face of the coil will be south, students. The direction of current will be clockwise, we consider. Agreed? There will be a deflection in the galvanometer. If the south is going away, south away, the polarity will be north. ये ध्यान में रखना. अगर मैं कोई solenoid देता हूँ students, ध्यान से देखना, अगर मैं solenoid देता हूँ and the current is said to flow, okay, current is said to flow in a solenoid, students, current is clockwise, polarity at the face of the coil will be south. So the polarity at the face of the coil will be south, we consider. So if I have a magnet, if I have a magnet coming closer, then what's the polarity I'm getting it? I'm getting it in terms of south. This is how I'll get it. The polarity of the face of the coil will be south, current will be clockwise. यानी कि magnet नजदीक आ रहा है. Students, अगर मैं solenoid do या closed coil do, to find the direction of induced current, I'm going to use Lenz's law. Opposes the cause. But now when I go for straight current carrying conductor, students, I'm going to use Fleming's right-hand rule. What exactly Fleming's right-hand rule speaks about? Please, FBI, Federal Bureau of Investigation. Your index finger, students, your first finger speaks about direction of magnetic field. Agreed? Your thumb represents your direction of force. दोनों दिया होगा तुम्हें फाइंड आउट करना है डायरेक्शन ऑफ करंट. क्या इतना क्लियर हुआ स्टूडेंट्स? हाँ स्टूडेंट्स, ये ध्यान रखना स्टूडेंट्स. Fleming's left hand rule is used in DC motor and deflection in galvanometer. I getting it? Restoring torque, deflecting torque का कंसेप्ट हमने पढ़ा था स्टूडेंट्स. वहां पे डायरेक्शन ऑफ फोर्स को फाइंड आउट करने के लिए था. ओके, यहाँ पे induced energy के लिए to get the direction of induced current, there are two ways of it. Either for a closed coil or for a solenoid. देखो दोनों केस में मैंने क्या किया है, मैग्नेट को I'm taking closer. ये मेरा solenoid था, मैंने मैग्नेट को नजदीक लेके आया. Students, I'm taking a magnet closer. When the magnet is coming closer, students, this is one diagram separate, this is second diagram separate, and this is the diagram. So this is the first diagram, second diagram, third diagram. Please make it very clear. If the south is approaching towards a solenoid, will there be current? Yes. The polarity over here will be south. This is how the flow of current will be. ये south होगा तो ये north होगा, यहाँ पे north आ जाएगा. लेकिन straight conductor होगा तो FBI students. Okay. Mutually perpendicular to each other. Index finger direction of this magnetic field, direction of current, and direction of force. Now let us understand with respect to your induction and energy transference. Pay attention for the diagram, students. Please pay attention now. Suppose if in case if I have a rectangular coil, students, okay. And this rectangular coil, students, I'm taking it as A, B, C, D. And I'm trying to move this particular coil in this direction. So there is some force acting onto it. I'm applying force onto this and I'm dragging it in this direction. Students, okay. At the same time, there is an external magnetic field. Let us say that the length of this particular ED, I'll take it as L. Okay, this distance I'll consider DC to be as X. So now there is a magnetic field through which I'm making it to pass. And suppose if I see the magnetic field is crossed, shown over here. This is length L. Okay. Now please pay attention, students. What exactly cross stands for? What exactly cross stands for? What will be the answer? So cross stands for magnetic field into and perpendicular to the plane of coil. Is there any force acting? Yes, sir, there is a force acting in this direction. Students, when there is a force acting, on a current on a straight conductor, on a straight conductor, on a straight conductor. There's no current, but I'm making the coil to move in an external magnetic field. Will there be any current induced? Yes, because there is change in flux. So ध्यान से देखो, अगर सपोज मैं कॉइल को इस तरफ ले रहा हूँ तो ध्यान से देखना, लुक एट माय डायग्राम, पॉइंट बी एंड पॉइंट सी का पोजीशन चेंज हो जाएगा. अगर मैं पीछे की तरफ लेता हूं तो लेट अस अज्यूम दैट बी रीचेस टू बी डैश, सी रीचेस टू सी डैश. So can I say A will reach to A dash, B will reach to D dash? So can I say this is what the displacement is? Dx. Do we have change in area? Of course, students, there is change in area. What exactly change in area I can consider will be length into breadth. क्या ये clear हुआ? Now, students, is there any change into area? Students, are you getting it? Is this correct? So length into breadth we consider. So यहाँ पे is there any induced current? Yes. Can I get the direction of current? Can I get the direction of current? That's a Fleming's right hand rule. डायरेक्शन ऑफ करंट करना चाहिए तो स्टूडेंट्स राइट हैंड रूल, फोर्स चाहिए तो लेफ्ट हैंड रूल. ये ध्यान में रखना. डायरेक्शन ऑफ करंट चाहिए तो राइट हैंड रूल. नाउ लुक ओवर राइट हैंड रूल, देयर इज अ फोर्स एक्टिंग दिस डायरेक्शन. हाउ इज द फील्ड गोइंग? इनटू. स्टूडेंट्स, फोर्स इज इन दिस डायरेक्शन, फील्ड इज गोइंग इनटू. देयर इज अ करंट. Upwards. That means will there be direction of current? Yes, sir, there is direction of current, and the direction of current will move from D to A, then from A to B, and then from, suppose if I take a galvanometer over here, or if I take a bulb, please students try to understand. अगर मैंने bulb को ले लिया, load यहाँ पे ले लिया, okay, so what exactly the current will get complete in that case, and the bulb will glow. So it will be glowing in the bulb. This is the fixed resistance that consider. Yeah, there is some current flowing in this particular coil. How did I get the current? So because there is change in flux. Students, there is change in flux. क्या ये clear हुआ students? Now, when this particular coil is moving in the forward direction, students, is there any force acting on AD, current carrying conductor? Which is that force? Fleming's force. Left hand rule. Please, everybody be with me now. I'm just drawing this part of it. So we had current flowing. What is the direction of current? D to A. Is there any magnetic field? Ask the magnetic field hai. How's the magnetic field? The magnetic field is going inside. Is there any current? Yes, there is some current. What is there any force acting? Yes, use Fleming's left hand rule. Field is going in that direction. Current is upwards. Is there any force acting onto it? Yes, sir, there is a force acting onto it. ये कौन सा force होगा? Sir, ये होगा force acting on a current carrying conductor, and that I can consider in terms of Lorentz force. Students, यहाँ पे जो force है, students, ये जो force है वो applied force हुआ. Students, इसको हम बोलेंगे force applied. ये क्या होगा? Restoring type का force हो जाएगा. Students, are you getting it? Means, am I trying to do some work? Yes, we are trying to do work. Work is done against which force? Against this force. So when I say work done is applied force. That's is applied. Sorry, work done is equal to applied force into displacement dx. Both of them in same direction, so cos of 0 1 होगा. Agreed? लेकिन ये applied force क्या होगा? मतलब सर applied force is equal to the force due to Lorentz. And what is the formula for force due to Lorentz, students? Equal in magnitude, opposite in direction होगा. What is force due to Lorentz? So force due to Lorentz is equal to B-I-L. है ना? Theta will be maximum. So can I say theta is 90, so sin theta is maximum. Students, क्या ये समझ में आया? Applied force and the force due to Lorentz, they're equal in magnitude and they're opposite in direction. So can I put F is equal to negative BIL? So now can I write down my formula, students? Can I run my formula for dw? तो dw को कैसे लिखूंगा? So minus, ध्यान से देखना, ये f के जगह पे क्या लिखूंगा मैं? Minus f into dx. F के जगह पे what exactly considered to be my applied force and restoring force are equal manner in opposite direction. So can I say if I happen to write on this one, so can I say this will be minus BIL. Agreed into dx, students. क्या ये clear हुआ students सबको? Students, is this clear to all of y'all? Now that's just enough. differentiating both the sides with respect to time because you're moving with respect to some time. So can I say dw by dt, which is equal to negative bil dx by dt. So what is dx by dt? What is dx by dt we consider? I can consider in terms of v, velocity I can consider. Agreed. ये क्या है? Work done per unit time. What is work done in unit time? I can consider as power. Which power is this, students? Electric power. Students, ये कौन सा power है? Electric power. Electric power is defined as a rate at which work is done. And electric power can be written as what? E into I. So students, can I write down E into I is equal to negative BIL into V? Can I say I gets cancelled? So what exactly the formula for E will be equal to negative BLV? Students, is this clear to all of your students? What exactly of flux is? Students, what exactly of flux we consider is? So flux we consider is equal to what? B into A. अगर मैं पूछूं what is rate of change of flux? Students, what is rate of change of flux? Rate of change of flux को कैसे लिखोगे तुम? Rate of change of flux को कैसे लिखोगे? सर ये होगा B into A को कैसे लिखोगे? Area को क्या लिखोगे? So this will be small area because of flux is very small we consider. Differentiating with respect to time dt I consider students. तो ये क्या होगा? ध्यान से देखना students. Everybody be with me now. What is d phi by dt? d phi by dt को कैसे लिखोगे students? B तो है. What is d by dt? Sir, L into dx by dt. है ना? तो देखो ध्यान से देखना students. d phi by dt is also equal to dlv. Students, one equation is d phi by dt is blv. Other equation is E is equal to negative blv. Am I getting mathematically now correct? Now correct that E is equal to negative d phi by dt. देखो, right hand side I can consider. I can equate this in that case with a negative sign. With a negative sign, how many loops you see it? How many turns you see? So we see only one turn. So what exactly the number of turns I can consider will be equal to 1. Students, आया तुम्हारा formula देखो. We were trying to get the formula E is equal to BLB. Am I getting E is equal to BLB? Yes. Am I getting E equal to negative d phi by dt? Yes, I'm getting negative d phi by dt. Students, ये पहले मैंने directly तुम्हारे पे थोप दिया था. Students, ये जो formula मैंने पहले बोल दिया था, कैसे बोला था? सिर्फ law की वजह से बोला था. क्या बोला था? Rate of change of magnetic flux linked to the closed coil is directly proportional to the induced EMF and takes place in its direction we consider. My dear, one is in negative, other one is in positive. So can I run BLV O here as d phi by dt? So can I put E as negative d phi by dt? I'm just trying to substitute BLV as d phi by dt over here. Jagannath, if you have anything, unmute yourself and ask. Don't type. Okay, students. So students, we have got the relation. ये मैंने directly बोला था और ये हम लोग ने भी बता दिया. तो इसका मतलब क्या हुआ स्टूडेंट्स? ये मैथमेटिकल वे ऑफ रिप्रेजेंटेशन. वापस बोल रहा हूँ स्टूडेंट्स, अगर मैं इस तरफ को खींच रहा हूँ तो मेरा अप्लाइड फोर्स हो जाएगा. डिस्प्लेसमेंट dx है, but my applied force and the force due to Lorentz are equal in magnitude opposite in direction. तो minus f. F का फॉर्मूला क्या है? BIL, the negative sign. So can I write f की जगह पे minus BIL into dx, differentiating both the sides with respect to time. तो सिंपल आ रहा है dx by dt को मैंने v ले लिया है, लेकिन इलेक्ट्रिक पावर क्या बोलोगे? पावर इज इक्वल टू व्हाट वी कंसीडर v into I square r. v square r कहाँ पे पढ़ा था? 10वीं में पढ़ा था कि नहीं पढ़ा था? तो पावर इज इक्वल टू e into I. तो e को मैंने डाल दिया यहाँ पे. I gets cancelled, so E is equal to negative BLB. Can I run E equal to BLB in this case also? Yes, why not? I can consider EMF we consider in terms of negative d phi by dt. Since negative sign simply shows that it's the direction of induced EMF, and that is in a straight conductor we consider. Is this part clear with all of your students? अभी आंसर्स देना students. इसी के related questions होते हैं मालूम है students. They can ask you students. Suppose if I try to consider an aircraft, Once an aircraft is flying into the air, will there be any induced EMF set up at the ends of the wings of the aircraft? Students? Will there be any induced EMF set up at the ends of the wings of an aircraft? Students, इसके simple problems कैसे पूछेंगे मालूम है? Yes. Students, absolutely correct जगह. Students, ध्यान से देखना. Please, everybody listen carefully. सोचो कि ये north है और ये south है. Please, everybody listen carefully. Okay, field lines they enter through south. It goes in this manner. और north से बाहर आ रहा है और ऐसा field lines आ रही है ना students? ये है तुम्हारी field lines. It's like the students. Please understand this. Questions पूछेंगे ऐसे. ना सपोज अगर मैं कोई एयरक्राफ्ट ड्रॉ करता हूँ स्टूडेंट, ध्यान से सुनना. अगर कोई एयरक्राफ्ट है स्टूडेंट्स और ये एयरक्राफ्ट की जो विंग्स है, ओके, ये जो विंग्स है, इफ यू सी इट फ्रेंड्स, ये जो विंग्स है, कैन आई से ये पॉइंट P हुआ, ये पॉइंट Q हुआ विंग्स का. मींस कैन आई से इट बिकम्स माय लेंथ ऑफ द कंडक्टर. कैन आई से दिस इज द लेंथ ऑफ अ metal conductor. If I say north to south, means can I say the field lines are cutting the rod. जैसे कि हम वो वार को, ये वार था और ये फील्ड था, है ना. जैसे जैसे मैं वार को लेके जा रहा तो फील्ड तो पास हो रही थी ना, और वार को लेके जा रहा था मैं, है ना, लूप वाला था. अब भी मैंने किया तो was the var was in motion, yes. was there any external, यहाँ पे कांस्टेंट फील्ड है. लेकिन अभी ये क्या कर रहा है, ध्यान से सुनना. अगर तुम्हारा विंग, स्टूडेंट ध्यान से सुनना, अगर तुम्हारा विंग ईस्ट वेस्ट डायरेक्शन में है, वेस्ट और ईस्ट के डायरेक्शन में है, that means the wing is cutting the magnetic field lines. Students, it is cutting the magnetic field lines. Will there be any induced EMF? Yes. अगर मैं यहाँ पे एक voltmeter connect करूँगा ना, there will be a potential difference between the ends of it. There will be current generated at the ends of the wing. Students, यानी pilots who are actually flying at high altitudes, there is an electric field created between the two ends we consider, लेकिन उसको earthing दे देते हैं, तभी जाके तुम्हें अंदर शॉक वगैरह फील नहीं होता है. इसके क्वेश्चंस पूछता है. लेकिन तुम्हारा विंग का पोजीशन कौन से डायरेक्शन में होना चाहिए, वेस्ट ईस्ट. क्या ये क्लियर हुआ स्टूडेंट्स? हाँ स्टूडेंट्स, इज दिस क्लियर? सिंपल फॉर्मूला क्या है, E इज इक्वल टू BLV, बस दैट्स ऑल. बी कौन सा है, अर्थ का मैग्नेटिक फील्ड वो देंगे, L लेंथ ऑफ द विंग दे देंगे, V क्या है, वेलोसिटी ऑफ द एयरक्राफ्ट दे देंगे, हो गया. अभी इसी को हम चेंज करते हैं, इसी को चेंज करते हैं. अभी मैं एयरक्राफ्ट को निकाल देता हूँ. ठीक है, if I remove this particular aircraft, if I'm trying to remove it, students, ध्यान से सुनना. Okay, and now suppose if I say that a train, okay, a train is moving from south of India to north of India. A train is moving from south of India to north of India. Train is so can I say ये जो wheel है, ट्रेन के जो wheels है, उसका axle यानी rod होगा, ये metal rod हुआ. क्या स्टूडेंट्स, ये मेटल रॉड जो कनेक्टेड है, क्या वो फील्ड उसको कट करेगी कि नहीं करेगी? हाँ स्टूडेंट्स, is the earth's magnetic field cutting the axle of the wheel of the wagon? Yes or no? हाँ स्टूडेंट्स, कट हो रहा है स्टूडेंट्स, यानी व्हील्स के बीच में भी एक ईएमएफ जनरेट होता है स्टूडेंट्स, करंट प्रोड्यूस होता है, और वो करंट को क्या करते हैं, मतलब अर्थिंग कर देते हैं. तो एट टाइम स्टूडेंट्स, वैगन के नीचे, ट्रेन के नीचे एक कंडक्टिंग वायर वो छोड़ देते हैं, और शायद तुमने कभी कोई ट्रेन को जाते हुए देखा होगा या लॉन्ग है, तो वहां पे वो फ्रिक्शन की वजह से स्पार्क भी क्रिएट करेगा. Exactly same thing we consider with respect to, for example, the huge luggage trucks, luggage baggages वाले luggage trucks जो long distances से आ रहे हैं ना students, luggage जो long distances से आ रहे हैं students, if they move from south to north students, अगर वो साउथ टू नॉर्थ जा रहा है लगेज, वो व्हील्स ट्रॉलीज, उनका भी Students, जो luggage वाले होते हैं, trolleys or we consider trucks we consider, उनके axle के across भी EMF generate होगा. The students, there is always an earthing wire given, and that wire is brushing towards the road surface all the time. Generated current is passed to the earth. Earth is simply considered as zero resistance. We consider. Is this clear to all of you, students? How would Earth of planes wings while it's flying? Students, just hold for a moment. There's an inspector come at my place. Just hold for a moment, please. Sorry, students. Okay, Jagannath, what was your query? What was your query? But how would planes wings when it's flying? My dear, earthing can be given. Earthing can be given to any electrical sockets where you connect it to the neutral wire. Okay, you connect it to the neutral wire, we consider. Okay, and they might be having certain system where the entire current has been swallowed in that case. Can be considered somewhere or the other, and the current generator is not too large enough at that. क्योंकि वहां पे high altitudes पे Jagannath, air becomes much more thinner. You're getting it? When it becomes much more thinner, in that case, you do not have that much amount of free ions availability as compared to that we consider on the Earth's surface at high voltage. Is it clear? So students, the formula we consider is what? E is equal to simply BLV we take. Okay, students. Now let's move further, students. Okay. Students, now when you speak about, since we got the formula for E is equal to BLV and E is equal to negative d pi by dt, students, we got it. Okay, suppose if I make a conductor to rotate, okay, in an external uniform magnetic field, students. Please pay attention to this, students. Okay, suppose if I have a conductor, okay, a conductor is said to rotate in an external uniform magnetic field. What's the mathematical relation? It's rotation, students, rotating. It's made to rotate. Hence, can I say for this particular conductor, suppose if the length of the conductor is AB, students, I'm taking an infinitesimal element. Please pay attention for this part of it. Okay. This actually speaks about what? A conducting bar rotating around a pivoted end. यहाँ पे मैंने एक pivoted करके रखा हुआ. This is pivoted. A metal rod. Am I getting it? Rotating about fixed end in uniform magnetic field intensity. How can we say there is an induced EMF set up in that case? Let us understand that. जब भी ये ध्यान से सुना स्टूडेंट्स, ये पूरा रॉड रोटेट हो रहा है. प्लीज एवरीबॉडी लिसन केयरफुली. दिस इज द लास्ट डेरिवेशन आई एम डूइंग इट. ओके, ये रोटेट रॉड, ये जो रॉड है स्टूडेंट्स, ये रोटेट हो रहा है. इट्स रोटेटिंग. देयर इज फील्ड थ्रू आउट स्टूडेंट्स. फील्ड थ्रू आउट है, एंड इट्स रोटेटिंग इन एन एक्सटर्नल फील्ड स्टूडेंट्स. It's rotating in an external field. So can I say this element is experiencing a rotation? That means there is some velocity v with which this element is set to move. So will there be any induced EMF setup at the ends of this element? What's the formula for the induced EMF setup at the ends of this particular element we consider? So can I say this will be very small EMF induced? What's the formula? Magnetic field B, because the magnetic field is B. Agreed? The velocity with which the element is moving is V. What is the length of the element? Students, what is the length of the element? I'm taking the length of the element as DL. क्या ये क्लियर हुआ सबको? मैंने फॉर्मूला क्या लिया स्टूडेंट्स? E is equal to BLV. क्या ये क्लियर हुआ स्टूडेंट्स? ये तुम्हारा पाइवोटेड एंड है स्टूडेंट्स. पूरा रॉड को हम रोटेट कर रहे हैं. कहाँ पे? एक्सटर्नल मैग्नेटिक फील्ड में. फील्ड यूनिफॉर्म है, तो मैंने उसके ऊपर एक छोटा सा एलिमेंट लिया है जिसका लेंथ dl है. उसको नेट वेलोसिटी भी मिला. अगर ये एलिमेंट को वेलोसिटी भी है तो पूरे रॉड को भी तो वेलोसिटी भी है. स्टूडेंट्स, क्या ये समझ में आया? ईएमएफ इंड्यूस्ड. Yes, Jagannath, what happened? You want to say something? Want to speak?
No, sir, that happened by mistake.
Okay, fine. Now students,
Understood this.
yeah. Okay, now suppose if I want to go for the total EMF, मुझे चाहिए total EMF at the ends of the rod. Students, I want the total EMF between this point A and point B of the rod. So what should I go for? So integration of B into B into TL. What is integration of B will be? E. What kind of motion this is? Sir, it's the element. That's not. Each element is going to rotate. Hello, element is going to rotate in that case. What exactly of V is written in terms of, so V is equal to R into omega. So can I say L into omega? Students, ये कहाँ से concept मैंने उठाया? Circular motion से. So can I say integration of B? B की जगह पे क्या ना put omega into L into DL. Students, is this clear? Is this clear? Can I remove B constant? हाँ sir, B तो constant है. External magnetic field constant है. Angular frequency, हाँ sir, angular frequency is perpendicular to the plane. Omega is constant. उसको भी बाहर निकालूंगा. इंटीग्रेशन क्या होगा सर? इंटीग्रेशन ऑफ L into DL आ रहा है. What is integration of L into DL? Sir, E is equal to B into omega L square by 2. What is it? L square by 2. What exactly we consider? Your lower limit is what? 0. Upper limit is capital L. 0 to L. Suppose if I say the length of the entire rod is L, so can I say E is equal to B omega L square by 2? क्या ये क्लियर हुआ सबको? एंड ओमेगा कैन बी रिटन एज 2 pi f फ्रीक्वेंसी. स्टूडेंट्स ये सारे एमसीक्यूज है, ये मल्टीपल चॉइस क्वेश्चंस है. क्या ये क्लियर हुआ स्टूडेंट्स? स्टूडेंट्स हैव यू अंडरस्टूड? यस और नो? अभी इसी को मैं कहाँ पे इंट्रोड्यूस करूंगा स्टूडेंट्स? इसको मैं कहाँ पे इंट्रोड्यूस करूंगा? एक सिंपल क्वेश्चन वन कैन आस्क स्टूडेंट्स, इफ इन केस इफ यू हैपन टू गो फॉर द ट्राई टू अंडरस्टैंड दिस. सपोज अगर तुम बाइक चला रहे हो और तुम्हारा बाइक का जो व्हील है, स्टूडेंट ध्यान से सुनना, बाइक का जो व्हील है, बाइक का व्हील है, दैट इज कटिंग द मैग्नेटिक फील्ड ऑल द टाइम. यानी स्टूडेंट्स you are trying to go from west to east and the field lines are moving from south to north. Have you seen the tires of the bike? Students, have you seen the tires of the bike? There are spokes. These are called as spokes. इसको पर problems पूछते हैं students. वो पूछेंगे what is the potential difference between the center and the end of the spoke. तो तुम्हारा आंसर क्या होगा? सर ये रोटेट हो रहा है ना, ये मैग्नेटिक फील्ड जा रही है, देखो ना, ये मैग्नेटिक फील्ड जा रही है, ये फील्ड ऐसे जा रही है, ये फील्ड ऐसे जा रही है, ये फील्ड ऐसे जा रही है, और ये रॉड रोटेट हो रहा है. तो फॉर्मूला क्या होगा? B ओमेगा L स्क्वायर बाय 2. यानी स्टूडेंट्स अगर मैं पोटेंशियल डिफरेंस सेंटर का और एंड का निकालूं, पोटेंशियल डिफरेंस बिटवीन दिस एंड और पोटेंशियल बिटवीन दिस एंड विल रिमेन द सेम. What is the potential difference between the ends of any two spokes is exactly equal to the potential difference between the center and the other. Will remain constant. Work. इसके रिलेटेड भी प्रॉब्लम्स पूछते हैं. यानी स्टूडेंट्स ध्यान में रखना, एयरक्राफ्ट के प्रॉब्लम्स पूछ सकते हैं. आई गेटिंग इट? ट्रेन्स का एक्सेल के ऊपर भी प्रॉब्लम्स पूछ सकते हैं. और व्हीकल मूविंग अलोंग द रोड, उसके लिए भी एक्सेल के ऊपर पूछ सकते हैं. और रॉड व्हेन सेट टू रोटेट वी कंसीडर इन दैट केस आल्सो. Okay, when you go for the tire of a bike, there are spokes into it, rods inside it. So is there any potential difference set up at the ends of the rod? Why not? Provided that particular wheel is cutting the magnetic field lines. So if there is a cut in the magnetic field lines, there will be an induced EMF. And what's the formula? B omega L square by 2. Okay, students. So in the next lecture, students, we will be moving further ahead.